Hello, hello. Has anybody noticed DDN in the news this year at all? Just trying to think back for a minute, press releases, blah, blah. Has anybody, put your hands up if you remember seeing something about DDN in the past year? About half of the audience. I just asked somebody, Alf, can you put your hand up, right? What was it that you were remembering? Yeah, okay, okay. Reasonable start. Who else put their hand? Spec SFS results, nice, nice. Was there one more hand? Any more? Rosemary? Some containery stuff, yeah, good. Okay, I'm going to mix all that in here. Thanks for the contributions. So as you know, DDN specializes in data at scale. We've been doing that for 20 years. We are genuinely pretty unique in being a company that just does that and stays the course consistently over long periods of time, partnering with our customers on their data at scale challenges. Of course, those challenges are across the spectrum, so block, file, object. Does scalability mean IOPS? Does it mean throughput? Does it mean maintaining consistent latencies? Is it object and geo-distribution, or do we need to have a multi-tenanted system? All these concepts are part of sort of DDN's DNA. And customers across these many verticals have challenges that hit some of those points. What I'm going to talk about today is just a subset of these kind of pieces here. So 2018 is genuinely, I joined just over 6 years ago, and it's genuinely been the strongest year we've had across the board, both in terms of growth, but definitely, I mean, as VP of Product Management, liaising between the field and engineering, it's been a really tremendous year in delivering products that we think will really matter, that really apply themselves to the challenges our customers are seeing. And what I did here was I just sprinkled a few of the enhancements we made just in 2018 and roughly applied them to the use cases, the verticals, where they'll apply strongly. Of course, they apply in multiple use cases. And I'm going to go through just a handful of these, not all, because I think I've got 17 minutes and 24 seconds, 23 seconds, 20, yeah. So we're going to pick a handful of those and drill down a little bit. And I'll give you a flavor of, why Brett Weber is looking so exhausted. He's the VP of Engineering, I think that's there somewhere. And why I think it's been a very, very strong year for DDN in general. What I don't speak about, I think will be spoken about and covered in other presentations. So the Spec SFS stuff, I think you can see these little prop plots here. They kind of look the same because there's a big red thing going out to the right there. They're actually different benchmarks, and the red thing is DDN stretching out to the right and clearly beating the competition. But that will be talked about in other presentations later on. So firstly, products, data platforms, what's happened in 2018. So cheating a little bit, I slid in the IME 140. So IME has been a very strategic product for us. It's really radical in how it treats I/O. And really we've baked in 20 years of expertise in dealing with customer applications. And we've squeezed it into the IME technology. And what we did at the end of last year is just made that apply to a broader set of use cases by making the starting systems smaller, lower cost, so we can ship them out to customers who weren't the largest in the world, but then ship them out to mid-range customers. So the IME 140, we'll see a little bit about it later on. This is now kicking out just under 20 gigabytes a second and about 350K IOPS just in 1U. And it's got some beautiful characteristics when it comes to I/O and some very neat characteristics when it comes to managing failures. And if you go to the booth, you'll see a demo, and the demo will show us knocking out one IME system through I/O, knocking out a second IME system out of 4, so we've knocked out half the system, and we're still doing production I/O, so pretty cool stuff. Then moving across to the right there's the 200 NV and the 400 NV. So obviously we realized that things were going a bit flashy a few years ago, and we produced this product and we started engineering it about 2 years ago and launched it earlier this year. So the 200 NV and the 400 NV are NVMe flash, but it's got all that DDN technology baked in. So let me say what I mean by that. It's not just a system with some flash in it which you plug into your fiber channel and add some servers, blah, 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 blah. Right inside that 2U system, so that one you see there, is a complete parallel file system. So ready to go, nothing else needed. That 2U, you can plug it into an AI environment or plug it into a small HPC environment, and it'll give you a complete packaged parallel file system based on exascaler or gridscaler. All flash. Same for these guys over here. So we've got the mid-range 7990, and we've got the 18K. So as previously, we've got a mid-range system, which is suitable for anything up to 20 gigasecond in a single unit, or we go all the way to the world's fastest storage system, which is the 18K, and I'll show you some numbers on that shortly. So just in terms of engineering platforms and tuning the software, embedding the software into those things, it's been a really heavyweight year. And beyond that, we've had a new solutions engineering team run by William Bodin. Is he here? I'm not sure if he's here. And they've been taking essentially DDN technologies, our experience, our benchmarking facilities, which are pretty large, and some software engineering, bringing all those together to deliver rock-solid solutions to sort of emerging challenges. Now, we started this about 2 years ago, and that resulted in A3i. So A3i is really a new set of products which tunes the software, adds real software engineering, adds benchmarking and qualifications across the breadth of AI frameworks. And we call that A3i. So there's a bunch of products which we'll talk about in a few slides. So one other technology which probably we haven't even launched this one yet, so this will be coming out this week, I think with a press release today, tomorrow, whatever, DDN data flow. And I think many people have worked with DDN in data management. And we have worked with many, many products over the years, including AFM. So we've both had our fingers burned and had successes. And we've got an awful lot of expertise around the services in DDN globally about how you do backups, how you do archives, how you do data migration, and how you can synchronize two file systems, two separate namespaces in two domains, and do that well. DDN data flow is really us coming up with a single set of technologies which can do the breadth of those functions, and not only apply to DDN storage, not only apply to gridscaler, exascaler, or WAS or object store, but also applying that to third-party systems, be that S3 in the cloud or tape library systems. So number one thing, we're not going to talk about in depth here, but we've got a nice demo on the booth. DDN data flow is our software for moving, transferring, syncing, backing, archiving data between systems, storage systems, and other storage systems, be that third-party or DDN. So if you did anybody say A3i? Who put their hands up and meant A3i? There must have been somebody there. That was, oh, George, thanks. Are you just putting your hand up to be nice? Are you? No, good, yeah, fine. So A3i was an awful lot of work. We did a huge amount of benchmarks, and then we went back into the engineering team, a software engineering team, to make some changes to adapt our technologies to fit these new AI workloads. Firstly, we did that with NVIDIA, with the DGX-1 system. DGX-1 has got some funny characteristics. It runs containers. It's got lots of GPUs packed into one operating system, and it's got a pile of InfiniBand links coming out of that thing. That's a weird kind of shape for a supercomputing company, which tends to have these thin nodes, lots and lots of them, and we care about scale-out aggregate performance. It tends to be write-heavy. So the opposite workload is the case here. So it took some work to really perfect that stuff, and I think we've done that. We do have some good experience, not just from this year, but from many years hence in really massive scale AI systems. One of the major challenges is in autonomous vehicles. The second major challenge is life science, and the third one is in finance. There are many others, but we see particular take-up of DDN technologies across those sectors. In automotive, there's a big problem that DDN can obviously help with. These vehicles are traveling around the city, multiple cities in a region, in a country, and each vehicle is carrying in video data, LiDAR data, radar data, so terabytes and terabytes picked up, driving around the streets, which needs to be dumped into a system. That accumulates on a city level, on a global level, to be really hundreds of petabytes of scale. And there's not really many companies who you can go to and ask them to cope with hundreds of petabytes at scale and also keep it reasonably simple and also give you holistic performance across the board. So we did a lot of work in making sure our systems were packaged and well suited to those kind of workloads, but it wasn't hard from where we started. The other little, you see the little dot science there? We did some investment in a group of very talented individuals and formed a little company called DotScience. And they're doing something interesting from DDN's standpoint. So we've always been close to the applications, but really coming from the storage level. We're close to the applications because we do parallel file systems, and that forces us to, because we've got to mount things on the clients, and they talk directly to the applications. Therefore, we've got to understand that conversation that's happening there. With DotScience, we're really reaching out and going beyond. So we're starting at the organizational level and thinking, what about data from that level there? And what DotScience does, I'm not going to give into too many details, but what DotScience does is, if you are an AI house with a bunch of data scientists, there are two sort of gaps in the market right now. Gap one is, how do I work out how well my data science is doing? How do I track the flow of images, the data scientist activity, get a holistic view of all the neural network training that's happening in my environment? And secondly, and probably more importantly, ultimately, is how do I find what happened when my vehicle turns left at the traffic lights when it's red? How do I go back and find out what that neural network was trained by who, with what data, etc.? So this DotScience is looking at that problem. It's looking at how to track and audit these AI data workflows at a really high-level organizational level. A use case two, and this is probably, I think we have a lot of life scientists in the audience. Please put your hands if you're in life sciences of some sort. We've just had the crick on. Yeah, it's pretty big. Now, you guys are the worst and the best. Definitely the toughest data challenges are out there in life sciences. As regards AI, of course, it's about, primarily we see it's about getting large-scale images from microscopes or scannings and inferring medical diagnoses from the images that come out of that thing. And there's three kind of mini use cases that happen there. One is we need a really simple system we can plug in a hospital, in a clinical environment, that's going to be able to perform the inference on large ingests of data from a scanning system or a microscope in a clinical environment. So simplicity is key, as well as being compact and not producing too much heat and being practical in a clinical environment. On the other side, in production, we need something that's really going to be able to give the flash performance, but also scale big, because the data volumes when you're doing neural network training, deep learning, by its nature is very large data volumes. So we've developed A3i to really cover that spectrum, to be easy to use, so extremely well packaged, taking the complexity and sophisticating of parallel file systems and really shrinking them down as small as they'll go. And also providing a scaling option, which gives you, basically, if you're starting out in this world with a single DGX-1 or a single Apollo 6500, you know that you can start small but still scale big without any worries there. Here's a little result we had with a little company called Microvolution, who does this just what I was talking about. They help deconvolute these images that come off these scanning microscopes, and that means they take the image and they convolute it with an algorithm which basically corresponds to the distortion that happened to undo that thing. So they do that very well, and they do it with GPUs. And this requires a lot of data movements. And you can see there's little plots here. You probably can't see what it says, but essentially look at the red, the blue, and the green lines. Red is more like NFS. Blue is like using the pack of raided SSDs inside the DGX. And then the green one on the top there, of course, is the AI200, which is our first product to launch within the A3i brand. Now, the point really isn't that we're faster than everything else. Fine, we're kind of used to that. But we're doing that in a shared environment, which is, of course, makes life much easier when you're managing this data at scale and scaling out multiple DGX, et cetera, et cetera. This performance enhancements, we still do serious numbers here, and there's some very serious numbers on this slide. So remember, we're talking about a 2U system with a whole file system packed in. In 2U with the AI200, this is this AI-optimized 2U NVMe platform. This red line is showing about 800K random reads and about 23 gigabytes a second throughput in 2U. Now, the AI400 looks the same. It's still 2U, still the same number of NVMe devices. We just put more horsepower inside that system. Now we're hitting over 46 gigabytes a second in 2U and 1.4 million IOPS. So genuinely, file system performance delivered to applications is really huge compared to any of our competition right now. What does that really mean for scalable GPU environments? So we did some work with HPE. HPE have a system called the Apollo 6500, which is 8 GPUs packed in a system, quite flexible, attached by InfiniBand. They've got a benchmark lab which allowed us to run our AI200, a single system, with up to 128 GPUs. And you can see the graph here. They have the same hardware for NFS as with the AI200. And you can clearly see that we continue enabling some scaling of the application where NFS causes a bottleneck at some point as we grow the number of devices. Okay, we've done data flow, come and see our demo. Done A3i, come and see more demos down in the booth. One of the big ones this year is the 18K. So this top-of-the-range systems have been kind of pretty flagship for DDN for a while. And the 18K is really the best, obviously, we've had so far. So it will succeed the 14KX. It's in a similar package. It's a 4U high controller system. And we've packed in more processor performance, more memory bandwidth, more PCI bandwidth, more network bandwidth. And, of course, it's running now SFAOS 11. Who knows what SFAOS 11 does that old SFAOSs didn't? That's going to be a tough one. Yeah, very good, very good. So this sounds simple, but it's really not. So decluttered RAID, we've been talking about it for a while, and we actually put it into production about this time last year, but now it's seriously storming. So all our systems now ship with decluttered RAID, SFAOS 11, and we're getting some extremely good results. Of course, the point of decluttered RAID is to minimize that rebuild time and to maximize the resilience of your data. But we've had some nice side effects in terms of performance and extracting more performance out of the drives. Here we see an 18K, and we've got a pile of enclosures. In this case, we see 10. You can scale up to 20 of those disk enclosures underneath that single SFA 18K head, that single controller. So that's going to be around 20 petabytes plus behind a single controller. So you can see when an AI company, an automotive company comes to us and says, give us 200 petabytes, whereas somebody else will come up with a very complex system with extreme large numbers of components, we're going to come up with a simple building block of 20 petabytes to go. So this scaling really matters at the very high end. Just to show it's real, this isn't just bad marketing doing a bad job at putting JPEGs together. That's a photo I got Skyped to me 3 days ago from a real 18K system being put together for an oil and gas company. You can see the benchmark numbers. So whilst this was swinging out to the customer, we parked it in benchmarking and see how fast it could go. And it turns out, with an embedded file system, so this is real file system performance, 2 applications, we get just over 60 gigabytes a second. That's pretty incredible from an embedded file system, just for you. And in this case, we're doing that from just 408 drives. So the efficiency is also excellent, and that's partly due to SFAOS, and it's partly due to these new enclosures we have here, these SS9012s, and the SAS backend of this system. So we can really extract all the performance of those drives, all the performance of those SSDs through this system. And then there's the little brother or little sister, the mid-range system, the 7990. And it comes in multiple flavors, just like the 18K. But here we see the same kind of story. We've taken it down to mid-range rather than top end. The 7990 is 4 rack units, starts at 4 rack units. And in this case, you can see these graphs over here, we've put in 80 drives and 160 drives to see how fast it will go. With just 80 drives, we're seeing about 14 gig a second. With 160 drives, and of course with more drives, we'll still keep creeping up in performance a little bit. We're just getting just under 20. We pack about 90 drives inside that enclosure, in that controller there. And then there's another 90 per enclosure as you add up. And then if you look at the IOPS, we definitely don't forget about IOPS, and we're hitting like nearly 800K as well. So again, very storming performance, definitely market leading, but this is more of a hybrid mid-range system. Hybrid because we can pack it with SAS, SSDs, or nearline SAS drives. And there you see another picture. You can even see, if you look carefully at the top there, you can see Matthias's little face. He's at the customer site installing that system, and I said, send me a picture. So he sent a picture of the back of the racks that he's just installing on a real customer site of about 10 of these systems right here. So these are 7990s with these SS9012 enclosures. And it's running SFAOS 11.0. So easy to deploy, all-in-one hybrid appliance, SAS or HDD, very capable in an extremely broad range of verticals. 45 seconds. We're going to hear a lot about Lustre, a lot about Scalar later on when Robert turns up. Right now, we're shipping GridScalar, Exascalar on all our systems. So from 7990, the 200NV, 18K, 14KX, V4, V5, upgrades between the two, across the board, you can get that across our systems. With the added benefit, no time to talk about it now, but lots of demos, we have this Insight system which provides scalable monitoring for all these platforms. So with 12 seconds to go, that was pretty quick, but there is a lot more, and we got a pile of demos. We got 5 demos running in the booth, including, what was that company called? Tintree, yeah, Tintree by DDN. We acquired that company a few months ago, and it's doing really well. We're extremely pleased, and that helps us get a great insight into the world of enterprise and the world of analytics. So some cool stuff to see there. We've got a demo in the booth. See the A3i demo, see the SpecSFS results where we trounce the competition with all 5 benchmarks. Talk about our partnerships with HPE and NVIDIA, and if you've got the time, there's some cool secret stuff which I'd like to tell you about that's coming to market more like 2019, 2020. We'd love to talk to you about. With that, thank you very much. I guess we'll take a couple of questions. Thanks.